Good morning, everyone. Thank you for joining our webinar. Nikki Kruger will be starting part 2 of the Dripping Point Evolving Codes webinar in just a few moments. We'll wait a couple of minutes so people can get logged in. And just a few housekeeping comments. Everyone is on mute. We'll be having a Q&A at the end of the webinar. And if you could, please use the chat feature throughout the event, and we'll read them off at the end. And also, if you are here to receive AIA, NATE, or BPI credits, you'll have needed to attend the Part 1 webinar that was held on May 6th. And like in Part 1, there will be a special code at the end of the webinar you'll need to write down. So to receive credits, email Nikki both codes and she'll get you set up.
All right, good morning, everyone. I am going to go ahead and get started here. We have a lot of information to cover today. Again, this is part 2 of a 2-part series titled The Dripping Point. If you didn't make the first webinar, you can let me know that and send me an email with I'll give my contact information at the end of this one, and we can send you a recorded link to that first one. All right. So just as a recap, Ultra Aire is a brand by Thermistore. Thermistore is our overarching company. We manufacture several different dehumidifiers, including the Ultra Aire whole house ventilating dehumidifiers, Santa Fe, which is the basement and crawl space dehumidifiers, Quest is our commercial line, and Phoenix is our restoration line of equipment. So the key takeaways from part 1, just as a quick review: houses becoming tighter and requiring less sensible conditioning, yet our moisture loads or our latent loads are the same or possibly increasing. We need to set up our air conditioners to remove as much possible as water when they are running without creating any other issues. If you are using air conditioning as your primary source of dehumidification, you need to remember that there has to be a sensible load in order for the air conditioner to run and remove humidity, no matter what kind of air conditioning system you're using. Houses work until you put people in them. Again, that thermostat on the wall is their comfort control center, and as soon as they're uncomfortable, they're going to start pushing buttons. And you can't always control how they're going to do that. So if it's run by temperature, they might not be removing enough moisture in that house. And people want homes that are safe, healthy, durable, comfortable, and efficient all of the time. So today we're going to discuss ventilation strategies in humid and mixed humid climates, dehumidification strategies, dehumidifier sizing, install options, and then also energy costs. So we'll kick off with ventilation here. So ventilation is the solution to pollution. All of the country at this point, as part of their building codes, does require some sort of mechanical ventilation. If you're building an Energy Star home, net zero energy, anything that would have to utilize the EPA Indoor Air Plus, you are required to use mechanical ventilation. So depending on the home, if it's a leaky home, we might have natural ventilation, but obviously as our homes get tighter and tighter, we need to implement mechanical ventilation in order to dilute the indoor pollutants. So when we talk about humid, mixed humid climates, what part of the country is that? So if you look on the right side of the screen here, this is the climate zone map, and at the top it has a line and it says moist and it has an arrow. So if you follow that line down, that is basically the parts of the country that need to have most likely some dehumidification at some point during the year. And that really does correlate with the map on the left, which is a dew point map from last September. And it shows us where our high dew points were pretty much exactly the same as that map on the right. And that's where we're going to discuss really how, from a ventilation standpoint, how do we implement effective ventilation strategies in this part of the country. So ventilation load index. This is a study that was done actually in 1997 by a good friend of ours, Lou Harriman. And they looked at, when we look at loads in a house, what kind of loads the ventilation air contributing. So we have our latent and our sensible. And if we look down below, obviously we've got a lot of moisture coming in our homes in Miami, more latent than sensible. So, and I think for the majority of this, besides Phoenix, Colorado Springs, Albuquerque, and Vegas, the majority of our ventilation load to the home is going to be the moisture. And I think we've seen this through a study with that Armin Rudd did with the DOE, that mechanical ventilation operated at 62 to 2010 rates in a 3 ACH 50 house is going to raise the annual medium indoor RH by almost 10% compared to a 7 ACH 50 house without mechanical ventilation. So tighter homes that require mechanical ventilation typically are going to have higher RH. And this was in Orlando, but when we look at that climate zone where there's high dew points, there's going to be a lot of moisture in that air outside. I found this article that Mike Moore wrote to HVI, the heating or the home ventilating institute, concerning when Florida was looking at going to requiring mechanical ventilation at 3 ACH 50. And it's a really great chart that shows us. So on the left-hand side, we can see the building air tightness. So 3 ACH 50, 5 ACH 50. And then on the far right, we can see what percentage less than code that tightness is stopping of natural ventilation. So a 3 ACH 50 house has 65% less than code or standard minimum ventilation. So it really is showing that the tighter our houses get, how much we are stopping that natural ventilation, which is the goal. We want to really be able to minimize our HVAC run times based on the outside getting into the inside. But we are going to have to provide fresh air. And right here, Mike included this in his letter that he wrote to HVI about how tight these Florida houses are getting, and that studies were going to indicate that the net effect will increase occupant formaldehyde exposure by 40%, and then even higher in the hot, humid conditions when formaldehyde emissions are much higher. So as we discussed before, the higher that the RH is in a home, the quicker that our materials in our house, cabinets, furniture, building materials, are going to off-gas that formaldehyde. So mechanical ventilation is very important in our tighter homes. We have to dilute that indoor air pollution. So our ventilation strategies, we have exhaust, which typically is our bathroom and kitchen. We have supply, which is just typically using a fan to bring in outdoor air, and in humid and mixed humid climates, we like to use the supply ventilation to create a slight positive pressure in the house, and it also provides some makeup air for our kitchen hoods and baths. And then balanced ventilation, which is our HRVs and ERVs. So exhaust ventilation, we need to use our bath fans and our kitchen hoods. Bath fans typically need to run about 30 minutes after the shower shuts off. So it's not go in, take a shower, leave the bathroom, shut off the fan. We really need to maximize the runtime in order to remove the moisture from that space. But this should not be a primary ventilation strategy in a humid and mixed humid climates. I know it is an option for Energy Star that you can use bath fan to run continuous or based on a timer system. But what we need to remember is 1 CFM out is 1 CFM in. So as soon as you start exhausting, you are going to be bringing in ventilation through other cracks and crevices in the home. So when it's hot outside and it's humid outside and you're sucking in that air, you don't know what surfaces it's going to hit and possibly condense. So most homes in the mid-Atlantic and the South, where I'm getting a majority of calls on mold, moisture issues, the first thing we do is go in and shut off that continuous ventilation. Continuous exhaust ventilation, sorry. So supply ventilation. Supply ventilation is what our ventilating dehumidifiers provide. If installed and designed correctly, it should provide the intended ventilation that you're looking for, which of course means we need our ductwork for that ventilation pulled tight. Not a lot of runs, not a long run or continuous bends in it, but we should be able to get that desired ventilation CFM that we're after with a supply ventilation. Again, we're going to do that slight positive pressure, which is really good in a humid and mixed humid climate to try to stop that infiltration. Minimizes combustion safety issues. Now, the air that you're bringing in can be filtered through our dehumidifier. We have a MERV 13 filter. Now, if the dehumidifier is running at the time that we're bringing in outdoor air, we can remove a little bit of moisture from that. And obviously, if the HVAC system's running at that time, we can get some precondition. We're going to mix that air really well before it's distributed throughout the house, and is fairly doable in a retrofit situation. So how much ventilation is possible? So we get this question a lot on how to figure out what size dehumidifier you might need for a house and how much ventilation you can get. And the max ventilation that you can get from one of our dehumidifiers is 1/3 of the total CFM. So here is our spec sheet, and this is for the Ultra Aire 98. And if we look at the column there with all the different listed CFMs, we have 320 with no static on that system. 290 CFM with 0.2 inches of water column, and then we're at 215. So it's important that we know what our static pressures are on that system in order to be able to figure out the max, again, that we're going to be able to get through that dehumidifier. Now, we do have the dedicated duct for ventilation on all of our dehumidifiers, except for the Ultra Aire 70 pint, because the footprint of the unit is so small, so you have to tie in to the return of the dehumidifier. And then our in-wall dehumidifier does not provide any ventilation. So, and then you can adjust that, the duct has a damper in it that you can adjust to set your ventilation. Obviously, you're going to have to test it to make sure that you're bringing in what you need. But again, the max that you can get is about 1/3 of the total CFM of the unit. So the ventilating part of how ventilating dehumidifiers work. We get a lot of questions on this as well, so we're going to break it down here. So if you're not running continuous, ventilation is then based on a timer system. So you'll have a controller, whether it's our DH3000 controller, or you're integrating our system with a thermostat that provides ventilation control, but you can set it up based on a timer system if you're not running continuous. When there is a call for ventilation, the dehumidifier's fan is going to turn on and the mechanical damper is going to open. Air is pulled from the outside through the MERV 13 filter into the dehumidifier. If the dehumidifier is running, which means the compressor of the dehumidifier is on due to there's high relative humidity levels in the living space, and there's a call for ventilation, at that point, then some moisture from the incoming outdoor air will be dehumidified. If the dehumidifier is not running, meaning the compressor is not running, and ventilation air will mix with the return air from the living space and the dehumidifier and then be delivered to the living space. So when the RH levels in the living space rise above the relative humidity set point, the dehumidifier will turn on. Dehumidifying ventilation air before it enters the home is ineffective and uses a lot of energy and will be expensive. So this is a residential ventilation strategy. I know in commercial there are products that will dehumidify air before it is delivered to the space, but in residential that really is very energy intensive to do that. So we really care about what the RH is in the living space, and we're going to bring in that outdoor air, and when that RH in the living space gets above the set point, then we'll dehumidify the entire home. But ventilation through our dehumidifier really is to bring in that dedicated CFM in order to provide effective ventilation to the space. So ERVs. ERVs will always reduce the moisture load in the home, but it's never going to reduce it to a dedicated set point. So it's always going to lessen the load that you were bringing in for outdoor air, but it's always going to contribute continuously to the moisture load in the house. It's just not going to be bringing in as much if you were just doing an exhaust or a supply strategy. So ideally, if customers can afford it, I know that if you watch Matt Reisinger's videos, and Matt is a huge supporter of ours, in his higher end custom homes, if his customers who can afford it will always put in a ERV and a dedicated dehumidifier. But in his homes where he has to pick one or the other, he will always choose the ventilating dehumidifier over the ERV because, again, the ERV will always contribute to the moisture load. So we did a case study down in Orlando, Florida, with a home, and it had an ERV in it. And you can see here on the right side where it says spring week with an ERV. The blue line there is the relative humidity in the living space. The red line is the outdoor temperature, and the green line is the outside dew point. And basically, by using that ERV, it was following the dew points outside. It was bringing in moisture, again, less moisture than using a different ventilation strategy, but it was still bringing in moisture to the space. So what we did after we did some data logging and ran that ERV, we took out the ERV and put in a ventilating dehumidifier, used it for ventilation to meet the ventilation code, set the RH to 50%. And again, the green line there is the dew point. We really don't care what the dew points are outside. We're going to focus on controlling that relative humidity inside to a dedicated RH set point. And Armin Rudd did a study with the DOE that basically supported that ERVs are ineffective in keeping indoor RH down during floating hours, when the difference between the indoor and outdoor absolute humidity is small. So if it's humid outside and it's humid inside, there's going to be very little latent exchange going on in the core of that ERV. It's really when you have larger deltas T's between that you're going to get more moisture removal. So a lot of questions that we get concerning using our dehumidifiers for ventilation is, you know, if it's cold outside or hot outside, I don't want to be delivering, you know, that 30-degree air directly into the living space. And the reality is we are mixing with the return air from the living space at the same time. So if we're bringing in, let's say, 50 CFM of outdoor air with our 70-pint dehumidifier, that means we're bringing in 100 CFM from the living space. and mixing it in the dehumidifier and then delivering it to the living space. So in this illustration here, the top, this is showing one of our heat recovery ventilator or dehumidifiers. The outdoor air is 30 degrees and the indoor air on the left-hand side is 70 degrees. We're going to bring in the outdoor air and that return air into the dehumidifier, mix it, and then our outlet air is going to be 59 degrees. So it's not 30-degree temps that we're delivering to the living space. And as you can see below, where we just use a heat recovery ventilator as the illustration, because again, we're not doing any latent, active latent exchange going on here. The outdoor air coming in is 30 degrees and the outlet air into the space is 58 degrees. So not far off in temperature there. If we look at it during the summer season, we've got 90-degree air outside and that dehumidifier is going to deliver 75-degree air because again, we're mixing with the living space air. And the HRV would deliver about 80-degree air. So still it's a very effective ventilation strategy that's not going to add a tremendous amount of sensible on the house or the living space, different than what an ERV or an HRV would do. So how much dehumidification does a home need based on ventilation? We have an app, a free app called, if you go into your app store for Android or iPhone, it is the Ultra Air Psychrometric app. And basically it allows us to take the conditions outside, what we want inside, and then put in what our CFM is. So the inlet on the screen here is what the conditions are outside. So 88 degrees outside, 65% RH was a 75-degree dew point. The outlet, what I want in my home, in here for the example, we have 74 degrees, 52% RH, and a 55-degree dew point. And the flow is the CFM. That's my ventilation rate. So based on those conditions, this is telling me at a ventilation rate of 100 CFM, I'm going to need about 106 pints of water removal a day. So we're going to break that down into a couple different scenarios here. So summer peak load conditions, I've got 93 degrees, 74-degree dew point. The outlet in my house is 7550, which really should be our ACA design or manual J design conditions right there. And I have 100 CFM, so I'm going to need 104 pints of water removal a day. Now, running at that peak load, my AC system is probably doing an okay job of keeping up with that moisture load if it's running at peak conditions for a large part of the day. So what happens when we get into our partial load conditions? So we have 85 degrees, 61% RH, 70-degree dew point outside. There's my indoor design conditions that I want. I still have my 100 CFM of outdoor air, and I'm going to need 74 pints of water removal a day. So I've got to figure out if my AC system is not running, how am I going to get that water removal? And then we go into no load conditions. So this is our 70 degrees and raining. Not running any AC, most likely. 100 CFM of outdoor air. I'm going to need 91 pints of moisture removal a day. And these are just based on ventilation. So if you have, if we need to calculate also the occupants in the home. So family of 4 would be about 2 pints or pounds of moisture an hour as well. So we would need to add that load onto this as well. So our dehumidification strategies, we have single stage air conditioning, variable speed, mini split, and then the whole house dehumidifier. And we're going to discuss the challenges with that from the AC side. Again, air conditioning is designed to reach a temperature set point. It's based on sensible. Now they do have dehumidification options. Most of the time, if it's not reheat, which very little of them typically are, it is overcooling to dehumidify. So it will be running longer, most likely at slower fan speeds to remove more moisture. So again, overcooling to dehumidify, and this does not address 70 and raining. So most likely there is no air conditioning running when our temperatures get cooler. And the reality is our houses are getting tighter and tighter, that the change in temperature is very slow. There's not a lot of runtime on our ACs when we're building tighter and tighter. This was my house last July, and this just goes to show that you can effectively dehumidify with air conditioning if you have no air sealing and basically very little insulation and lots of natural ventilation in your home. So I have a 1950s home that, again, no air sealing. I actually did some thermal imaging on my ceiling in my living room this day, and I was reaching temps of 112 degrees on the ceiling in my living room. So I've definitely got some work to do. But when your air conditioner runs all the time and you have high energy bills, you can effectively even over dehumidify, as you can see at this 33%, where typically I wake up in the winter and my contacts are sticking to my eyes, but this was definitely happening in the summertime. So not an efficient way to dehumidify, and again, became very uncomfortable because I was over dehumidifying. So mechanical systems do need typically about 15 to 20 minutes of effective runtime in order to really get water dripping down the drain. So we don't want to oversize our mechanicals. We want to make sure that we right size as much as possible to get longer run times in order to get that effective dehumidification from the systems. So variable speed. Slows the air conditioning down, we can remove more moisture, and this is what we had talked about in part one webinar about really maximizing our air conditioners to remove as much moisture as possible without creating any issues. And again, it makes a smaller amount of colder air, so we have to be careful that we're not getting condensation anywhere in our ductwork, registers. We still need to be delivering air to the farthest points of where the ductwork ends. So we still got to get to that comfort as well. We can't just be overcooling to dehumidify and not getting our air to the farthest points of the house. And again, doesn't solve 70 and raining. And ductless mini splits, most of them that I have seen, we talked about sensible heat ratios at the last webinar. They're very effective at getting to that sensible temperature, but again, not a lot of latent removal by the ductless mini splits. They are designed to condition smaller spaces to get to that temperature, and most of their dehumidification modes are based on a timer situation, and you can quickly overcool a space. So you have to be very, very careful when you're using that dehumidification mode on the mini splits. And then we have a whole house ventilating dehumidifier, and these integrate with the HVAC system, and we're going to discuss some installs here. But again, we are going to dehumidify that space, the living space, based on a set RH point. So let the air conditioner come on, get to that sensible, that temperature set point on the thermostat. When it shuts off and the relative humidity is still too high in the space, then the dehumidifier can come on. And the dehumidifier is really going to shine in the shoulder seasons where we're not running a lot of AC. In the evenings, again, a lot of times people get up, start cranking down that thermostat in the middle of the night because they're uncomfortable. And most of the time it's not a temperature situation. It is a sticky, they're uncomfortable because the moisture is too high and they feel sticky. So dehumidifier sizing, as you can see here, we offer a lot of different models and sizes of dehumidifiers. So we get asked a lot, how to size a dehumidifier. And if you look at our spec sheets and go to our website, traditionally we have, and I think all dehumidifier manufacturers are this way, based on sizing. And we are very, very conservative in our sizing of our dehumidifiers because we want it to be successful. It's harder to oversize a dehumidifier, but it's easy to undersize one, and you don't want your homeowners to be upset when they've paid this money for this dehumidifier and it's not working. So square footages, I would say that we are very conservative. Be careful when you look at other companies going by square footages because they can get a little aggressive. And again, if you undersize that dehumidifier, you are going to have unhappy homeowners. And there's other ways of sizing that we're going to discuss here as well. But again, what you'll see traditionally used is square footages. So how to size dehumidifiers. First of all, we gotta define what our goal is. So I work with a lot of builders, custom builders, production builders, multifamily developers, HVAC contractors, homeowners, and we need to know what the goal is for the application. Is the goal to control the relative humidity to a certain set point, 50%, 55%, all the time, regardless of AC runtime? Or is it to protect the property, and if we wet and dry a little bit, it's okay, it doesn't have to be precise? Do we have people with health issues that have to have it set? So really understanding what the goal is for the situation helps us to define of exactly what our strategy is going to be to size that dehumidifier. So we know that the AC is going to remove approximately 2 to 3 pints per ton when running. So it has to be running in order for that water for longer periods running to go down the drain. And then how has that AC system been sized? So are we using the manual J and manual S to get our calculations to know how that AC's been sized? And is it been oversized? Is it a little undersized? That's going to help us understand a little bit more how much latent removal we're getting from that air conditioner. Also, how often is it running at these conditions? So when we're sizing it using manual J, we're getting peak load conditions. And how often do we run at those peak load conditions? Typically about 1% of the time. So we've got to figure out how we're going to get our latent removal all the other times when our AC system potentially is only running at that peak load 1% of the time, and we need to supplement that with additional dehumidification. How much fresh air are we bringing in? So again, based on our climate zone, how much moisture are we bringing into the home, and how are we going to deal with that? 70 and raining, how are we going to deal with all that extra moisture in the air that we're bringing in? And dedicated dehumidification will always control the relative humidity regardless of the AC runtime. So we need to keep that in our minds when we're thinking about our mechanical strategies. So designing for code, this is from the 2018 IECC. When we're doing our manual J's, the least amount, or the minimum temperature that we can design for is 75. They recommend 78 based on requiring programmable thermostats be set by the manufacturers at 78 degrees. So if you're following 2018 IECC, programmable thermostats now have to come from the manufacturer with a set point of 78. Obviously that can be changed, and then the minimum that we can use in our manual J's for design is 75 degrees. We can't go any lower than that for designing our systems. Now, we have worked with builders who have come to us and said, listen, we have a customer that wants it 68 degrees in their house all the time, and a relative humidity, an RH of 45%. By code, you can't design for that. You have to follow the Manual J and the code guidelines. So our best practices. We've got an indoor design cooling temp of 78. We've got our outdoor design temp of 96, 50% relative humidity, 4 people inside. Our ventilation rate is 71 CFM, and this is going to tell us our sizing for this system is going to be based on 36,000 total BTUs of cooling, and then it's going to give us our sensible load and our latent load. So that 7170 is our latent load. So based on Manual J, how do we calculate dehumidification? So the latent cooling, which is our 7170, is going to be divided by 1,054 because it takes 1,054 BTUs to remove 1 pint of water, and we're going to times that by 24 hours in a day, and that's going to give us our dehumidifier sizing. So again, that's 7170 divided by 1,054, and then we're going to times that by 24 hours a day, and that's telling us that we need 163 pints per day of water removal. So are we going to count on our AC system to handle that? Or are we going to pick a dehumidifier that will handle all that load, or just supplement the AC when it isn't running? So those are decisions that, that we're going to have to make. And I will tell you that working more and more with builders, and definitely more of the forward-thinking HVAC contractors and mechanical engineers, they are looking at addressing all that latent load with a dehumidifier and not leaving it up to the homeowner to run air conditioning in order to always be able to maintain that 50 to 55% RH in the home. So if we look at Manual S, on page 49 of Manual S, it discusses for several pages actually how to size dehumidifiers. And a lot of people don't even realize that is in Manual S, but it is. And we currently are working with ACA on providing updates to Manual S for their dehumidification section. So pints per day equals 24 hours in a day times the latent BTU divided by 1,054. So again, it's kind of just working it backwards. And again, we still end up with that 163 pints per day. And then also Manual J says, okay, but now we need to adjust a dehumidifier pints per day for 75 degrees and 55% RH, because all dehumidifiers are rated at 80 degrees and 60% relative humidity traditionally in the past. Now, the DOE has come up with new testing conditions for whole house versus crawl space and basement, but right now Manual S says we need to adjust the pints for that 75 degrees and 55% relative humidity. So if you were to take our 205 pint unit and do the 0.76 multiplier to get for that 75 and 55, it's going to tell you that that 205 pint dehumidifier is really about 156 pints. So dehumidifier sizing limits, you need to adjust the dehumidifier capacity must be equal to or greater than 85% of the latent cooling load for that 75 degrees and 55% RH indoors. So again, this all is in Manual S. It starts on page 49. So what's interesting again is when we talk about sizing dehumidifiers and getting our Manual J's or our Manual J load conditions at peak conditions. This is a chart that a good friend of mine, Kimberly Llewellyn with Mitsubishi, put together, and basically this is showing us all the partial load conditions throughout the year where we're at that 50 to 60% temperature range and a 50 or a higher degree dew point. So I think this is above a 55 degree dew point here. So Miami, I mean, we got 43 over 4,300 hours in a year that we're at these partial load conditions with really high outdoor dew points. Jacksonville, I mean, even Phoenix, down at the way bottom, we get that monsoon season. So these are all the hours in the year in these locations that we are not running at peak load, and we're going to have to figure out how we're going to control that humidity and figure out what size dehumidifier we're going to need in order to be able to control that. So here is a performance. This was our 105 XT 105 dehumidifier, and this is at the 0.4 water columns of static. And you can see at 80 degrees on the left-hand side over the 60% RH, when we add the static pressure, that reduces the output of what that the dehumidification of that dehumidifier. So performance data is really important, and something that we are adding to all our dehumidifiers at the new DOE conditions. So very important to know that, again, dehumidifiers are rated at, in the past, at 80, 60 for those pints of water removal, and we need to think about the different conditions we're putting those in and getting those performance curves. And this is for our 205 unit. So again, this is 0.4 water columns, and that 205 at 70 degrees and 60% relative humidity is 153 pints. So dehumidifier installs, we're going to have to fly through this kind of quickly here as we're coming up on time, but if you have any questions that we don't get covered, make sure that you email me and I can make sure to address those as well. So dehumidifier installs, our recommended install is a dedicated return to the dehumidifier, and then we're going to tie into the supply of the HVAC system. So this allows us to run the dehumidifier without ever running the fan on our air handler. So this is the most energy efficient way to set up a dehumidifier. And in our install instructions, we'll tell you exactly how to install these, the backdraft damper that you need installed there. But again, this is our recommended install. Now, you don't have to use us for fresh air ventilation. You can use us just for dehumidification, but we always give you that option to use this for dehumidification or for ventilation as well. So this is how it looks as an illustration here. We're going to pull in air from that dedicated return into the dehumidifier with the fan. And then we're going to, if we want to, we can utilize the dehumidifier to bring in that outdoor air. And this is showing one of our XT units with that heat exchanger inside. We mix the air inside the dehumidifier. We're going to run it through the evaporator coil, have water go down the drain. And then we're going to deliver it back into the living space, and we're just utilizing the ductwork to distribute that dry air. So an alternative install is the HVAC return to the HVAC supply, because a lot of times in retrofit especially, it's hard to pull that dedicated return. So here we're going to have to either use a check damper in that return before it gets into the air handler, or we're going to have to run the fan on that air handler to move that air through. We also have 2 HVAC systems install. Just got this question yesterday if this is a possibility. It absolutely is. So we can use one dehumidifier. Typically we see this in new construction tied to 2 systems, and then we're going to use a controller in a centralized area that's going to read the RH and deliver that dry air to both areas. No ductwork. A lot of times we are the ventilation, air mixing, air distribution, and dehumidification and ductless mini split applications. So we have homes that will install a dehumidifier with some minimal ductwork. The key on this one is off that supply to make sure that you have typically about three areas of supply where we're delivering that air, because again, dehumidifiers do create some warm air, and we want to make sure that we're getting that dry air throughout the whole house. Plus, if you're using us for ventilation, we want to be distributing that ventilation air as well. Return to return install. This is an option. It's a tricky option to get right, and we typically will not recommend it, although we do offer it in our manuals, because sometimes in a retrofit there is absolutely no other way to do it. You just have to make sure that you get this install exactly spot on. We have the instructions in our manuals, and you can call our customer service and they will help you with this. But this is a very challenging install to get correct. So much so that Florida Solar Energy about 2 years ago came out with a study on different dehumidifier installs. And basically, their conclusion was that a return to return is the most ineffective and energy intensive install, and they do not recommend it. And that's because when we'll go back here, when we're dehumidifying that air and putting it back into the return of the AC system, we're heating up the coils of the AC, which means it's removing less water. And then when that AC shuts off and the dehumidifier potentially is on, if that's how it's been set up, it's going to re-evaporate that air back into the living space. But again, you really reduce the latent capabilities of your AC system when you do this sort of install. But again, sometimes there's no other way around it, and there are very specific details that you can get right to make it more effective. Ducted dehumidifier is 100% outdoor air. We do not recommend this at all. You will not get the results that you want. Again, a dehumidifier, once it comes on, to bring in that outdoor air, if used in this way, we have to load the coils. So there's going to be several minutes of run time that you're bringing in that. And this unit would be a 70 pint unit, would be 150 CFM of outdoor air. That you're delivering into the AC system, that we're not removing any of that water. Once the dehumidifier does start removing water, it is generating heat, and it's the same scenario as we just talked about. This is being delivered into the AC system. We're going to heat up the coils on that AC system, reduce the latent removal. We do not recommend this install. And again, if we look at, our down below here, our outputs, if we just do it at the conditions up above of a 70, we have a dew point of 70, we're only decreasing that dew point to 60 if we're using it for 100% fresh air. Now, if we set it up to bring in 50 CFM of fresh air and pull 100 CFM from the indoors, from our return, this allows us to get that dew point down to 50. So it's far more effective to set it up our recommended install than it is for 100% fresh air. So energy costs. Our goal, of course, what we talked about according to Manual J on our first webinar, is that 75-degree dry bulb temp with a 50% relative humidity. It's not the heat, it's the humidity. Humidity plays a huge role in how hot a given temperature feels. So again, how the temperature, if it's 90 degrees in Miami versus 90 degrees in Las Vegas, it feels much different. That's because our body is able to actually evaporate the sweat in Las Vegas versus just sit on our skin like in Miami. And the key to this is when humidity is lower, you will feel more comfortable at a higher temperature. So in reality, if you do have 50% relative humidity in a home, you should feel much more comfortable at 78 degrees on that thermostat. And actually, you know, people who do get dehumidifiers are surprised if they haven't changed their thermostat setting from, let's say, 74 degrees, how cold they feel with that dehumidifier, keeping it to that 50-55%, and they increase their thermostats. So Matt Reisinger did a really great video titled "Why Does My Texas Wife Take a Sweater to Dinner in July?" I highly recommend, and he talks about, you know, basically overcooling to dehumidify in that one. So our design goals matter. With AC, the energy in, what we're getting out of there is cold air. That's the goal. That's the design goal of the AC system. And that energy is calculated much different than a dehumidifier. With the energy going out, what's coming out is water, is the liter. And again, that's calculated much different. So how that looks is 1 kilowatt hour of energy input. Typically for an AC, you're going to get 2 to 3 pints of water removal. With a dehumidifier, you're going to get 5 to 9 pints of water. And according to Florida Solar Energy, each degree lower that the temperature is set, you set the temperature, the AC use goes up by 12%. So again, it's using the right tool for the outcome that you're looking for, and using as the least amount of energy as possible to get to that goal. So this was a second home energy savings study we did down in Ocala in the Villages, and they set their thermostat at 85 degrees. We had the RH set at, you know, I think it was 50 or 55 for the summer while they were back in the Northeast, because all we cared about was controlling the relative humidity while they were gone. And there was a 40% energy savings from the year before, where they tried to use a humidistat to control the AC to run versus a dehumidifier, because again, we just want to prevent any microbial growth typically when we have unoccupied homes. So capacity, energy factor, and calculations, these are all things that are very important, and you can do this on your own, or you can go to our website where we give you all this information on all our spec sheets and all the details of each unit. So, so this is the 98 pint, 6.1 pints per kilowatt hour, and then we also do liters because that's typically what the DOE and Energy Star use. There's also a program out there for RedCalc, redcalc.com. This is their ventilation electrical usage. I plugged in the watts of our 98 pint dehumidifier, which is 670. Guessed how many days of the year we were going to use it, 270. I'm going to use it 20 minutes of every hour of every day. So some days, some hours it might be more, some hours less. And then I just put in the kilowatt of 11 cents, and it's telling me that it's going to cost $159 to run that dehumidifier for that amount of time during the year. So you can play with that, and it'll show you really how little energy a dehumidifier or an energy efficient dehumidifier is going to use. And in the words of Dr. Joe Steenbrook, you cannot energy conserve your way to dry. It's going to cost you money to keep your homes dry, but ultimately indoor air quality is very important, and we really need to be thinking about that. And that is all I have for today. The code for today's presentation is #50%. And there's all my contact info for those that need their credits. So make sure you email me. And Jenny, do we have any questions?
We sure do.
Oh boy.
One universal question that has come up is, will this webinar be available, a recording of it? And I did answer privately with somebody, but to everybody, yes, this, for everybody who registered for the webinar, we have your email address and we will send you a link to the recording. So as far as the questions that came in, the very first one was when you were on your manual S slide. And the question is, where did the 1054 BTUS come from? I have always understood 970 BTU.
That is in manual S, and that is what we use. Is it takes, we always say approximately 1,000 BTUs to remove a pint of water, and the actual number is 1,054 BTUs. So I am not sure where it came from. I know it's in that whole explanation of BTUs where they talk about ice melting and all of that. So we can talk about that more offline if you want to shoot me an email.
Great. The next question comes in about manual S is, does the manual S multipliers for different indoor conditions generic to AL dehumidifiers, or does Ultra Air have their own multipliers?
That is universal for manual S's. They assume that, I think it was 0.79. Again, we have performance data for all of our dehumidifiers that we use at the different conditions based on testing. So that is just a generic multiplier.
And then from the same person, the DH ductwork configuration has always been an issue. Please comment on tying DH supply to AC supply, as it can't overcome the AC supply static. We have been successfully tying DH supply to AC return. DH return comes from the space.
Sure. So typically with our installs, the dehumidifier does not run when the AC is running. So there shouldn't be much of a static issue in that scenario. So on the supply side. So, you know, AC comes on, runs, shuts off, the relative humidity is still too high. So then the dehumidifier comes on and just utilizes that supply ductwork, and shouldn't be too much of a static issue. They're definitely, and I'm guessing this is I'm somebody that I've talked to out of Texas, because we have talked about them using the tying into the return, and it's been very successful. And again, it can be successful. We just want to caution that you really have to make sure you're getting that install correct. And if it's working for you, that's great. But it's not typically something. I got a call last summer from a contractor that put in one of our dehumidifiers and said, you know, 2 weeks later, the RH was raising in the house, and we couldn't figure out why. And the reason ultimately came down to was that return to return install, and we were blowing all the water off of the AC coils back into the living space. So made some modifications, and then we set it up correctly. It's just not as easy to get correct as our other install options, but it can be done.
Great. We do not have any other new questions coming in. I just wanted to make that last comment about making sure to write down the secret code, add it to your first code from the May 1st webinar, and email that to Nikki to get your credits. And right now, we don't have any new questions that come in, so.
All right. Well, if anybody thinks of anything, make sure you email me, and also get me those credits, and I will get those processed this week and get you your certificates. All right. We're all done, Jenny?
Yep.
All right. Thank you, everyone.